Hi, welcome to Mathmaxtra. This is Saritha. Today our topic is Apollonius theorem. So what is Apollonius theorem? So whenever you want to relate the medians and sides, so there you need to have an idea about Apollonius theorem. So what it states, it is a relation between the sides and median of the triangle. So what it states that the sum of the squares of any two sides, which is always equal to twice the sum of the squares of the median and the half of the side opposite to the median. Okay, so we'll see. So this is a triangle. This is a triangle ABC. Okay, so this is a median AD, right? So sum of the squares of the two sides, nothing but, so I am taking these two sides. Okay, AB square plus AC square. Okay, which is always equal to twice the sum of the squares of, this is a median, right? So sum of the squares of the median and half of the third side. So this is the third side we are considering, and this side, this BD is equal to CD, right? You can take either BD or CD, which is nothing but half of BC, right? This is BC by 2 and this is also BC by 2, right? This is half of BC. This is also half of BC. You can either write BD or you can write CD. So I am writing BD square. Okay, so this is the Apollonius theorem represents. See, sum of the squares of the two sides, which is always equal to 2 twice the sum of the squares of the median and half of the third side. Yes, so see, these AB, AC are sides of the triangle and this AD is the median of a triangle. So this is a relation between, wherever you get, you need to identify the relation between the medians and sides. There you need to remember this Apollonius theorem. So from this you can find the exact relationship between the sides and median, as well as you can find out length of the median, as well as you can find out length of the each side also. Okay, so we'll see in detail. So AB square plus AC square, which is equal to twice AD square plus BD is nothing but BC by 2, right? So I am writing BC by 2 in place of BD. So 2 times of AD square plus BC square by 2. See, you check why we are substituting BC by 2 in place of BD means, see, we always represent in terms of sides, right? That is why I am considering BC as a side. So BC by 2 I am representing. So this is the relation from one median. If you draw other median, this is B. Okay, what happens? From these two sides you have to consider BA and BC. This is what? AC by 2 and this is AC by 2. So how can you represent? AB square plus BC square. AB square plus BC square, which is always equal to what? 2 times of, what is the median? BE, right? So BE square plus, this is what? AC, right? AC square by 2. And similarly, if you have another median, this is CF. What it represents? It is AB by 2. And this is also AB by 2. So if you want to consider CF median, so these two sides, right? AC square plus BC square, which is equal to twice the CF square is the median and this is AB square by 2. These are the three equations. From these three equations, you will get by simplifying these three equations, you will get 3 times of sum of the squares of the sides AB square plus BC square plus AC square. It is always equal to 4 times of sum of the squares of medians AD square plus BE square plus CF square. C. So these are the sides of a triangle. These are the medians of a triangle. So what is the relation? 3 times of AB square plus BC square plus AC square, which is always equal to 4 times of AD square plus BE square plus CF square. So this you can get from these three. So you add up all left side terms and all right hand terms and simplify. You will get this. Okay. So what is the ratio of sum of the squares of sides divided by sum of the squares of medians? So which is equal to 4 by 3. So this relation is very important while solving the problem. And from this, okay, so from this relation you can find out length of the median also. See, AD is length of the median, right? So this one you can find out from this relation. So from this we will find out length of the median, that is AD. So you multiply both the sides with the 2. See, 2 times of AB square plus AC square, which is equal to 4 times of AD square plus BC square. So 4 times of AD square, which is equal to 2 times of AB square plus AC square minus BC square, which is equal to AD square is equal to 1 by 4 times of 2 times of AB square plus 2 times of AC square minus BC square, isn't it? So what is AD now? Which is nothing but half of under root of 2 times of AB square plus 2 times of AC square with minus BC square. This is the length of the median. Length of the median. Okay. So this is how we can calculate length of the median from this relation. Okay. So how can we remember this length of AD? See, this is a median, right? This AB side is this side and this AC side is this side. These two sides are either side of the median. So for that 2 times of AB square plus 2 times of AC square, and this BC is exactly opposite to the vertex, right? So that is why this is BC square is only once, that is minus BC square. So half of under root of 2 times of AB square plus 2 times of AC square minus BC square. This is the length of the median. So in similarly you can calculate BE median length as well as CF median length. Okay, and we have one more relation which is see these AG and BG, CG. These are nothing but parts of the medians, right? So this AD is a median, AG is a part of a median. This BE is a median, this BG is a part of a median. So we also have a relation between medians and parts of the medians. So we'll discuss one thing. So we know very well that is this centroid divides this median in the ratio of 2:1, right? So from that, how can we write AG? So AG is equal to 2/3 of AD, right? Similarly, BG is equal to 2/3 of BE, and CG is equal to 2/3 of CF. You add all left side terms on the left side, right side terms on the right side. Okay. So AG plus BG plus CG, which are equal to 2/3 of AD plus BE plus CF, right? So from this, what can we write? 3 times of sum of the parts of the median, which is equal to twice the sum of the medians. So we have this relation also. What is this? 3 times of AG plus BG plus CG. Nothing but 3 times of sum of the parts of the medians, which are equal to twice the sum of the parts of the median. So this is what one more relation from the Apollonius theorem. Okay. Thank you.